Hello everyone, hope you are doing well. I am Akshay Parmar, Assistant Professor at LJ Institute of Engineering and Technology in IT ICT department. Welcome to the video tutorial series of the data communication and the computer network. Today we will discuss about web and the one protocol, hypertext transfer protocol, which is working at the application layer, right? So have you all are knowing about what is web and what is web page, right? You all are surfing on the internet and you are all are using the websites also, right? So in the website is the collection of the web pages, right? So what is the web page contents and what is it having, right? So do you have any wild guesses? So yes, you are right. So web page is consist of an object, right? That object can be anything. It can be an HTML file, it can be a JPG file, it can be a PNG file, it can be a Java applet, it can be an audio file, it can be a video, or it can be a text or anything, right? So web pages are the consist of an objects, and that objects are anything that might be an HTML file, JPG file, PNG file, image file, video file, audio file, Java applets, textual formats, and all that thing, right? So the web page consists of a base HTML file which includes several reference objects, right? So that all the objects, for an example, then JPG file or audio file, they are having a reference to consist of that object, right? That is consist in a base HTML file. For an example, each object is addressable by an URL. For an example, we have one example about that. So this is then www.ljiet.edu. This is a web host name, right? In that you can find an pic.gif, right? So this is its path, some department / pic.gif. That is a path to that particular object, right? And what is its host? Its host is ljiet.edu, right? This is its host, and after that all is the path to that particular object, right? That's how that objects are linked with that web page, right? That all the objects can be a reference, right? That's how that things is working. After that, the hypertext transfer protocol, the most famous and most fundamental protocol which is working at an application layer, right? So web's application layer protocol is an hypertext transfer protocol, right? It is having a client server kind of model, right? So what do you mean by the client and what do you mean by the server? Yes, you all are right, right? Client is having a browser that can request and receive the information with the help of the HTTP protocol, and it displays its result as a web object, right? Server, yes, web server sends an object in response to the request, right? In the context of, if you are working in a PC, right, which is running on the Firefox browser, it can be running on the Safari browser, it can be running on the Chrome browser or anything, it can be running on the Opera browser or anything, right? It is simply requesting some kind of object from the server, right? The server is running on the Apache web server or any kind of the web servicing they are using, right? So in the context of that HTTP request which is sending from the client, server is doing some kind of computation, and after that, if it is having the required information or requested information from the client, then server is responding the HTTP request. The server is responding back to the client about that information, right? So that's how the client is getting its desired information, but it is not bound to any particular kind of system or architecture, right? If you are working on the PC or if you are working on any kind of mobile phone, for an example, if you are working on an iPhone or you are using a Safari browser, then also you can get an information with same as a PC, right? You can be use any Android phone, and you can use any iPhone phone, Apple system or anything, right? You are getting a same kind of desired information from the server itself, right? So that's how the client server system is working. After that, So HTTP uses an TCP, right? So that's how the TCP is working in the HTTP. The client initiate the TCP connection. It can be used at create and socket, right? As we have seen in the Python, that is command there, socket.socket, right? So the client initiate the TCP connection to the server. Yes, we are working in the HTTP. So the port number is 80 there, right? After getting that request, the initiated request from the client itself, the server accept that TCP connection from the client, right? After establishing that server connection, the HTTP message, which is working in an application layer protocol message, it is exchanged between the browser and the web server, right? The browser is working as an HTTP client, and the web server is working as an HTTP server, right? After the exchanging the desired information, or after exchanging the messages, the HTTP is closing the TCP connection, right? So that's how it is working. The HTTP isn't stateless, right? You have heard that the HTTP isn't stateless. So what do you mean by that HTTP is stateless and all that, right? So server maintains no information about the past client request, right? So if you are requesting some kind of information from the server, after responding back to the client, server is not maintaining any record about the information about the past client request, right? The protocol that maintains the state. So you have one question arise, why the HTTP is not maintaining that kind of the states, right? So the protocol that maintains states are really complex, right? The past history, or we can say that the state must be maintained if server or client crashes, right, their view of the state may inconsistent must be reconciled, right? So at that moment you need to store the state or the history, but in the HTTP that is the no need of that, right? So HTTP is not maintaining the record about the past client requests, right? After that, the HTTP connection has the mainly two types, right? It is the non-persistent HTTP and the persistent HTTP. So right, so what are the things are following under the non-persistent HTTP and the persistent HTTP, right? So in the non-persistent HTTP, at most one object sent over a TCP connection at that time, right? After sending in one object, the connection is closed. After that, the downloading multiple object require a multiple connection where you are working with the non-persistent HTTP. But if you want to send, or if you want to download a multiple object without requiring a multiple connection, if you want to download a multiple objects without requiring a multiple connection, then you can switch forward about the persistent HTTP. In the persistent HTTP, the multiple object can be sent over a single TCP connection between the client and the server, right? Where if you are working with a non-persistent HTTP, you need to establish a connection between the client and server for each of the object there, right? So that is the basic difference between the non-persistent HTTP and the persistent HTTP, right? So let's see how the non-persistent HTTP is working, right? Suppose user enters an URL, the www.ljiet.edu slash the some kind of path, right? Some kind of object, right? Here the user is seeking for the home.index file, right? Whose path is some department slash home.index, right? That URL contains a text reference to the that object is contain the text references to the 10 JPG images, right? So how it is working in the HTTP, right? So how it is working, let's see in the context of the non-persistent HTTP. The first of all, the HTTP client initiate the TCP connection to the HTTP server, that is processes at the host name, right? What is your host? The host is www.ljiet.edu, ljit.edu on the port 80 as we are using the HTTP services, right? After getting an after the www.ljit.edu is already waiting for some kind of connection coming to that toward them, right? So the HTTP server at the host ljit.edu is waiting for the TCP connection at the port number 18, right? After getting that request from the client itself, it is accepting that connection and notifying the client about it is accepted that request, right? After getting the information about the connection, after establishing the connection, the HTTP client sends an HTTP request message, the containing in the URL, right? It is containing about the some department slash home.index, right? In that they are into the TCP connection socket, right? In the TCP connection socket, the TCP client sending the HTTP request message. This message is a message which is having in the socket, that is indicates that the client wants an object some department slash home.index, right? After that, the HTTP server receives that request message that is coming from the HTTP client itself. In the form, it forms the respond message that containing the requested object and send the message into its socket itself. Likewise, the server is sending the desired object which is requested with from the client itself, right? So HTTP after the sending the desired information, the HTTP server closes the TCP connection, right? The HTTP connect client receives the response message containing the HTML file, displaying HTML file, then parsing HTML file, and find the 10 desired reference object, that is the JPG objects, right? So that's how the client is getting the desired input, the desired object from the server itself, right? After that, the step 1 to 5 is repeated for the each of the 10 JPG objects, right? As you all are knowing that the non-persisting HTTP, in that you need to form an each and individual connection with the server itself, right? So that steps are repeating for the each of the 10 objects. So let's discuss about the HTTP response time, right? So have you heard a term round trip time, right? Have you heard a term round trip time before? Yes, you are right. The time from a small packet to travel from client to server to client back, that time is called the round trip time, right? The HTTP response time, right? So in that, the client is first of all initiating the TCP connection with the server itself, right? So the client is initiating the TCP connection. It is requesting for the connection establishment, right? So it is establishing a socket with the server. After getting the server is already waiting for that kind of request. After getting that request, the server is establishing a connection with the client itself, right? So and it is acknowledging about the connection established. After that, the client can request the desired input or desired object, right? So that is called an one round trip time, right? So one round trip time is considered for the connection establishment, right? So TCP connection establishment is taking in one round trip time. After getting that, the connection is established, the client can request for the desired object, right? So the client is requesting for the some kind of object from the server itself, right? After that, after the server is getting that request for the particular object, the server is responding back to the so after that, the server is responding back to the client that this is your object, right? After that's how it is following the round trip time to saying the client that this is your desired object, right? And after the time, it is taking that some amount of time to transfer the whole object from server side to the client side, right? So the file transmission time, we can say that, right? So the total time for the HTTP response time is you are already knowing that the one round trip time is to initiate the TCP connection, right? And after that, the another one round trip time for the TCP request and first few bytes of the TCP respond to the return, right? That's how you are getting in 2 round trip time. After that, the file is transferring from the server to the client there, right? So that file transfer time is also there, right? So the total HTTP response time is the non-persistent HTTP response time is equal to 2 RTT plus particular file transmission time, right? So that's how the HTTP response time is the 2 RTT plus particular file transmission time, right? This is about the HTTP non-persistent HTTP response time, right? Let's see the difference between the non-persistent HTTP issues and the persistent HTTP issues, right? In the non-persistent HTTP, we required 2 round trip time per object, right? OS overhead for the each TCP connection, right? And browsers often open a parallel TCP connection to fetch and reference objects, right? And as in the persistent HTTP, the server leaves connection open after sending and response, right? The subsequent HTTP message between the same client and server sent over an open connection, where in the non-persistent HTTP connection, they are closing the connection after sending a particular object, but where in the persistent HTTP they are not closing a connection with the same client, right? The client sends a request as soon as it encountered a reference object, as little as the 1 round trip time for all the reference object. In the HTTP, in the non-persistent HTTP, we require 2 round trip time for the each and every object, right? But in the persistent HTTP, only 1 round trip time is required for each of the reference object, right? So that is the basic difference between the non-persistent HTTP and the persistent HTTP, right? After that, let's see an HTTP request message, how it is working. In that, the HTTP message, the request and the response, right? Here, first of all, you are the first is the request line. In that, you are sending, if you want to get the data or the post the data, right? If the client is requesting some kind of information from the server itself, so the request line must be the get at that time, right? And if someone is want to send an information, so that at that time you can use a request line post at that time, right? That are the head commands with context of that. After that, the HTTP index.html file is there, right? The object name is there, right? After that, the HTTP/1.1 is there. That is the carrier return character and the line feed character at the end. After that, some of the header lines are connected with that. In the header files, you are having an information about who is the host, who is the user, and after that which kind of basics they need to follow are there, right? And at the end, the connection is alive or not, that all are the information as following under the header line there, right? As an example, in the header line, the host name indicates the server name, right? The web server name is containing in the host itself. After that, the user agent, so whichever the browser is user is having, the user agent information is there, right? The Firefox browser is there and the version 3.6.10 is there, right? After that, which is the acceptance criteria with this context of this request or response, right? They are accepting the text or HTML file at the HTML application kind of thing, which kind of languages they are seeking for, which kind of encryption and encoding and decoding fundamentals are there, and which are the character sets they are working with. That all are the information as lying under the header lines, right? After establishing the connection, if the connection is alive or not, all are the information are there only, right? At the end, you are all are seeing that /r/n, that are the carriage return line feed to start of the line of the indicate the end of the header line, right? /n/r/n is the carriage return, right? The line feed at the start of the line indicates the end of the header lines, right? So you can observe that that's how the HTTP message is look alike, right? After that, you have seen that HTTP 1.1 is there, right? So basic different about the HTTP message type, right? If you are working with the HTTP 1.0, so in that you can work, you can request that get and post only, right? And in that get, post and head only. It in the simple HTTP 1.0, it is ask server to leave the requested object out of the response. Where if you are working with an HTTP 1.1, in that you can work with the get, post, head and put. Right? In the put, it uploads a file in the entity body to path specified in the URL field. Right? After that, you can have an delete functionality there. In that, the delete the file specified in the URL field, right? So that is the basic difference between an HTTP 1.0 and HTTP 1.1, right? So how the HTTP response is look alike, right? We have seen then HTTP request message. So this is the structure of the HTTP response message. The status line for the first line is the status line, right? The protocol and the status code and the status phrases is there. So here you can observe that HTTP 1.1 is there. After that, the status code and the status phrase is there. The 200 OK is the status phrase there. Right? So we will see which kind of status phase are working with the HTTP, right? After that, some kind of header lines are there only, right? So let's see the which kind of status codes are there, right? So in that the HTTP response status code, we have seen there are we have seen that HTTP 1.1 space 200 OK, right? So the 200 OK indicates the request succeed the requested objects later in this message, right? If you are having an 301 moved permanently, it is indicating that the requested object is moved to the new location specified later in this message, right? Which is having in the that location address is having in the location in the header field, right? After that, the 400 bad request, if you are seeing that those 400 bad requests, that means the requested message not understood by the server itself, right? If you are getting an 404 not found, the requested document is not found on the server itself, right? You have seen in 104 the file is not found the error so many times, right? If you are getting in 505 HTTP version not supported, right? So that's how that response code is indicating about the responses, right? After that, let's see how the cookies and caches is working. At the user server state, what is the cookies there, right? The cookies is a small piece of the data stored on the user's computer by the web browser while browsing the websites, right? It is designed to be reliable mechanism for the website to remember the stateful information. The cookies having the four basic components. The cookies header, line of the HTTP response message, right? Cookies header line in the next HTTP request message. The third component is the cookie file kept on the user's host, managed by the user's browser, right? So that cookie is managed by the user browser itself. And the fourth component is the backend database at the website, right? That is the four basic component whenever you are working with the cookies. For an example, the Akshay always access the internet from the PC, right? And it is visit a specific kind of e-commerce site for this first time. When it is initials the HTTP request arrive at the site creates a unique ID with respond to the e-commerce website which is requested from the Akshay itself. The entry in the backend database for the ID, right? So let's see how it is working. So let's see how the user and server states the cookie at that time, right? So there are the client and the server. The client is having an already and cookie file In that it is storing an information about the eBay, right? So it is an eBay and its ID is stored in the client server. It already was there, right? And after that the client is requesting some kind of unusual HTTP request, right? For an example, it is requesting about the Amazon server, right? So using an HTTP request message, it is sending to this server, the Amazon server, and creates an ID 1678 for a reference for the user itself, right? So and after that server is sending an HTTP response with that ID. The server is sending an usual HTTP response. It is sending that the set the cookie 1678 is with the client only, right? So the client is storing that cookie at its local machine or in the browser. Whenever the client requires some information from the Amazon, it can simply look in the cookie itself, right? In the cookie it is getting a unique ID in its cookie itself, right? So for the Amazon it is having an 1678, right? So with the help of that 1678 cookie which is stored at the client side, this usually requests a message for the cookie 178. After getting a specific cookie, it is taking an action, and that's how the user is getting the usual response from the server itself, right? After creating an Amazon server and creating ID 1678 for the user, it is simply storing in the backend database at the server side, right? It is create an entry for that particular user, right? After that, whenever the user is storing that cookie in that particular location and requesting the same website for with the help of that particular cookie, that cookie is get from the specific action. It is looking in the backend database which is already created by the server and the backend database there. After getting that particular unique ID, the backend database simply transfer the desired object to the user itself, right? After a 1 week or later, that cookie is already storing. So that cookie is already stored at the particular local machine, right? After a 1 week or particular time duration, the server, the client is want to information about similar kind of thing. It is visiting an Amazon or eBay. We can say that, right? At the client side, that is already two cookies there, for one for the eBay and one for the Amazon. If after a 1 week or later it is requesting for the Amazon or the eBay, that the with the usual HTTP request message, the cookie is 1678 or cookie is 18734, the cookie specific action is performed at the backend side, and in the backend database they are getting the information, they are fetching the information from the server that this particular cookie request is linked with that particular user, and this is the server request there, right? So that's how the particular HTTP response message is coming from the backend database and the server itself to the client itself, right? So that's how the cookie is maintaining at the client side and the server side, right? After that, let's see the web caches, the proxy server. It satisfies, where does that web caches uses, right? It satisfies the client request without involving an origin server, right? In the, as you have observed that in the cookie that origin server is involved, right? But with the, whenever you are working with a cache, the cache is a reserved storage location that collects the temporary data to help the website, browser and apps to load faster, whether it is a computer, laptop or phone or a web browser or an application. You will find some variety of the caches, right? A cache make it easy to quickly retrieve the data, which is in turn of the help to device the run faster, right? The user sets a browser and web access via cache. The browser sends all the HTTP requests to the cache objects in the cache. The cache returns object, else the cache request object from the origin server, then return object to the client itself, right? So that cache is stored in the particular proxy server. It is not linked with an origin server, right? So while we are working with the cache, the cache is stored at the one particular proxy server, right? So whenever the client wants an information from a particular server, so it is sending an information, so it is requesting in cache to the proxy server, right? It is sending an HTTP request to the proxy server. that after getting that catch, the proxy server is forwarding its HTTP request to the origin server, right? After getting the response from the origin server, the proxy server is redirecting that HTTP response to the client itself, right? After establishing that catch, if the client was the same kind of information from the that particular server, then the client is sending an HTTP request to the proxy server, and that proxy server is sending an HTTP request with the help of that catch only, right? Here the origin server is not engaging all the time whenever you are working with the catch, right? So let's see the some kind of proxy caches, right? Web caches. The cache act as a both client and the server. The proxy server is working as an server, right? And after that it is redirecting to the origin server, right? So at that time that proxy server is working as a client. After getting an information from the origin server, that proxy server is storing its cache at that proxy server, and it is responding back to the client itself, right? After some time the client is requesting the similar kind of thing. At that time the proxy server is working as a server itself, right? So the cache acts as a both client and the server itself. The server for the origin and the requesting the client to the origin server, right? Typically the cache is installed by the ISP, university, company or residential internet service provider. Why the web caching is useful? It is reducing the response time for the client request, right? It reduces the traffic on the institution's access link. Internet dense with the cache enables the poor content provided effective deliver content, right? So to does the peer-to-peer connection sharing, right? So that is the advantages about the caches also. So in this session we have seen and web and HTTP services, right? So that's all about today's session. Thank you for the watching.